now. Okay, are you guys all ready to go? Do you need a second to catch up, or are you guys good? Okay. You should have your toolkits out, and you should see that they should already be on there. So, did you guys write down anything for sine of 2 theta on the toolkit already? What do you guys have for sine 2 theta?
2 sine
Yeah.
theta cosine theta.
Good. It should be 2 times the sine of theta times the cosine of theta, right? Unfortunately, the sine of 2 theta is not the same thing as just, 2 times the sine of whatever theta that is. That's not what that means. So we're taking the sine of a double angle. All right? So for the cosine of 2 theta, which one did you guys write down? I believe you guys already have these in your toolkit. Which one did you write down?
Cosine
Yep.
theta minus
Cosine squared theta minus a sine squared of theta, right? But there are 2 others that I'd like you to write down as well. And the 2 others are this. You can have 1 minus 2 sine squared theta, and the other one you could have is 2 cosine squared theta minus 1. So you actually have 3 choices when you are dealing with the cosine of a double angle. All of these are a double angle in here. And then for the last one, that should already be written down for the tangent of 2 theta double angle formula. It should be written down as 2 tangent theta all divided by 1 minus tangent squared of theta. So everyone have those already on the toolkit? So far so good?
Yes.
All right, cool. We're good to go. Okay, so here's the setup. It's a very classic setup of what we'll be doing, types of problems we'll be working on for finding double angles. So they're going to give you some information. Sine of theta is 5/13. Theta is in quadrant number 2. They're going to ask you 3 parts, A, B, and C. Find sine 2 theta, cosine 2 theta, tangent 2 theta. All right? So we're going to work A, B, and C individually. And then I'm going to show you a little trick at the end to get C a little faster, a little part C a little bit faster, okay? The very first thing that we need to do, though, is what? If we were given information, we got to draw the picture. Very good. So we're going to go ahead and draw the picture. It's going to be in quadrant number 2, okay? It's going to be a right triangle. Here is angle theta. I am now in quadrant number 2. And what do I know about theta? I know something about theta, right?
sine is 5.
Yeah, its sine is 5/13, meaning that the opposite side needs to be a value of 5. The hypotenuse needs to be a value of 13. What does that leave the missing side to be? 12. Very good. But since it's in quadrant 2, it's going to be a negative 12. I'm going to circle that one so that we all know that's the one that we had to figure out on our own that was not given to us, okay? So I'm going to move this up a little bit because we have all the information we need in the picture right there. So for part A, we're going to figure out the sine then of 2 theta. Unfortunately, we can't just double 5/13, right? That's not what that means. Instead, sine of 2 theta means 2 times the sine of theta times the cosine of theta. So sine 2 theta then turns out to be 2 times, we know the sine of theta, and we're going to figure out the cosine of theta. According to our picture, the sine of theta is 5/13. That one was given to us, so multiply by 5/13. And the cosine of theta, if I look at the picture, would be what? Negative 12/13, right?
Yes.
The rest is just algebra. 2 times 5, that gives me 10, times negative 12 is negative 120. All divided by 13 times 13 is 169. Therefore, the exact value for sine 2 theta turns out to be negative 120 over 169. Straightforward plug and chug. Not very interesting, I agree, but nonetheless, part of our curriculum, we can get it done.
Is that what we're doing today?
Okay, let's do B, right? We're going to find the cosine then of 2 theta. All right. Now, remember, for cosine 2 theta, we have, this was sine 2 theta, we have 3 choices, right? So if you look back up here, here are the 3 choices that I've highlighted in this little box here, right? All of these, okay? Which one should we choose for this one and why, or does it even make a difference?
For which one?
Don't know. What's that? Why do you say the second one? Why do you say we should use this one? Why do we say that one?
Because you already have sine theta.
Because sine theta was the one that was given to us from the beginning, right? So we were given the sine of theta was 5/13. I mean, if we had messed up and calculated that missing side wasn't negative 12, we then carry that mistake over, right? So we should use the one that's given to us. So I'm going to go ahead and choose the one that's going to be 1 minus 2 sine squared of theta. Okay, so moving right along, I'm going to have 1 minus 2 times. Do I have a value for sine? Sure do. It's 5/13, right? And we're going to square that value. So that gives me 1 minus 2. Well, 5/13 squared is 25/169. Is that true?
Yes.
You guys cool with that part? Right? I'm going to move this up and out of the way. That gives me 1 minus 50/169. Right? Because 2 times 25 is that 50. And then I'm going to change that 1 into a 169 minus 50 all over 169. Does everybody understand? I made that 1 a 169 over 169 and then a common denominator, right? That's the whole point of having that common denominator.
You get 19 over 60.
So I'm getting a grand total of 169 minus 50 gives 119 all over 169. And that's my exact value for the cosine of 2 theta. And that's what I have so far. All right, you guys good with that? You feeling good? Okay, good. All right, let's do part C then. Okay, part C is going to be the tangent of 2 theta. Now, I only have one formula for the tangent of 2 theta, right? What is it?
2 tangent theta over 1 minus tangent squared
2 tan theta over 1 minus tangent squared
theta.
theta. Good. So that's going to be 2 times. Let's figure out the tangent of theta by looking at our picture. 5 over negative 12 or a negative 5/12, right? So it's going to be a negative 5/12 all divided by 1 minus a negative 5/12 quantity squared. You guys following the book so far? Easy enough? So 2 times a negative 5/12, that's a negative 10/12, right? All divided by 1 minus, this looks like 25/144. When I take 5/12 and square it. No, the negative part squared, yep, okay. So that's going to be negative 10/12. All divided by 144 minus 25 over 144. There's that common denominator trick again. Shows up. It's quite handy in these types of problems. So I'm getting negative 10/12. All divided by 144. Take away 25. What do you get? Anybody out there? Crickets. Huh? 119? Yep. 119 all over 144. We're going to flip and multiply. Negative 10 over 12 multiplied by a 144 over a 119. Check it out. I'm going to move this to the side just a little bit. So 144 divided by 12 is 12. So I'm finally getting negative 120 over 119. Okay? All right, now I told you there was a trick, right? I told you there was a trick for part C.
Wait, there's like all numbers.
Yes, maybe you're already seeing it. Or, I'll put an or over here. We know that the tangent of 2 theta is the same thing as the sine of 2 theta divided by the cosine of 2 theta. Now, didn't we figure out the sine of 2 theta for part A? It's in that box right there. And didn't we figure out the cosine of 2 theta? Isn't that one for part B? So can't we just write that as the sine of 2 theta was defined as negative 120 over 169, and the cosine of 2 theta was defined as 119 over 169. Notice these cancel out, and you're left with negative 120 over 119, which is exactly what we got over there. If you compare those two, I think the bottom one's a lot easier. So I want you to come up with the exact value for this. So what you need to do is look at the structure of the numerator and the denominator and see if you can find what that structure represents. Okay. Talk about it in your groups real quick. Good. Many of you saw that this was in the same structure as the tangent of 2 theta, where theta is represented by this value right here, right? So therefore, this becomes the tangent of 2 times 15 is 30 degrees, which is just a root 3 over 3. So therefore, all that stuff is just equal to a root 3 over 3. All right, guys, so we only have 6 minutes left in class, but I really want to get through this one identity. The last part of the day was you're going to try one on your own. And this is a straight up black diamond only because there are lots of places where along this path we could diverge and end up lost in the black diamond woods. Okay, so I'm going to guide you through, but then hopefully the next one you try on your own. So I really need at least this amount of time to get through this one, okay? So stay with me as long as you can. All right, so we're going to verify the identity. I'm going to move this up. We're trying to show that the cosine of 3 theta is 4 cosine cubed theta minus 3 cosine theta. So generally, what side would we start on before?
The left, but this time it looks like we're going to start on the right.
Well, which side looks harder to you, the left or the right? The right looks harder, right? And so normally we'd start with that one, but in this case, we're going to start on the left. Okay? So we're going to call this the cosine of, we're going to break up 3 theta into 2 theta plus theta. Okay? 3 theta is 2 theta plus a theta. Now, you should see that we have a sum formula for cosine. Do you see it? Yes. All right. Very good. So the sum formula for cosine says that we're going to have the cosine of 2 theta times the cosine of theta minus the sine of 2 theta times the sine of theta. That is the, look at the sum formula for cosine. Look up your toolkit in 5.2. Sum formula for cosine. You see it? All right, tricky, right? Tricky. No, they're different. One's 2 theta, one's theta, right? Okay, so now we know what we could do with the cosine of 2 theta and the sine of 2 theta. We have some choices for those, right? Now, remember, here's the thing you want to keep in mind, right? You're looking for an answer that only has cosines in it, right? So therefore, when I'm making my choice for the cosine of 2 theta, I'm going to pick the one that only has cosines in it, right? So which choice would that be of those 3? What's it going to be?
2 cosine squared theta minus 1.
Very good. So this is going to be 2 times the cosine squared theta minus 1. And then we're going to multiply that by cosine theta minus. Now, for sine of 2 theta, I don't have a lot of options, right? I only have one. What's it going to be? Change that to 2 sine theta cosine theta. And then I'll multiply that by sine theta. Does everybody see where that comes from? Okay, now I'm going to distribute my cosine in. Here it's going to give me 2 times cosine cubed theta minus cosine theta. Now I'm going to distribute my sine. It's going to be minus 2 sine squared theta cosine theta. All I did was distribute the cosine in and distribute the sine into that one term, right? What do you see now that we could do? We have 3 terms. They all have cosine in them, except this one. This one has a sine squared. Is there anything I can do with that one? Can I change sine squared into something with a cosine? Yes, I can. So I'm going to have 2 cosine cubed theta minus cosine theta minus 2 times, I can change sine squared to 1 minus cosine squared theta times cosine theta. Again, I'm going to distribute in my cosine. And I'm going to get 2 cosine cubed theta minus cosine theta minus 2 times, let's see here, there's going to be cosine theta and then minus a cosine cubed theta. So far so good? So this is algebra stuff, right? Then I'm going to distribute my 2 in to that one and to that one. And watch what happens. I'm going to have 2 cosine cubed theta minus cosine theta minus 2 cosine theta plus 2 cosine cubed thetas. All right, now everything is now in terms of cosine. So check this out. I have 2 cosine cubed thetas there and 2 cosine cubed thetas there. For what's the grand total of that would be? There you go. That would be your 4 cosine cubed thetas. Then in green, I have a negative cosine and a negative 2 cosine for a grand total of how many? There you go. A negative 3 cosine theta, which is exactly what that says way up there. So there's the whole problem. Start to finish, black diamond.